Hi grade 8s, we're moving on to our next topic in equations, which is solving equations with distribution. Now fortunately you know everything you need to know in order to solve equations. You need to know the golden rule and you need to know the idea of inverse operations. So all we're doing here is we're bringing in the idea of distribution into equations which we already know how to solve. So let's look at example 1. It says solve for x. Now this says 2 multiplied by a bracket which has x minus 1 in it, so there's more than one term, so that is distribution. So there's two ways to do this question. Probably, I think the more easy way, because it just makes more sense to me, is I would multiply the 2 into the bracket. So 2 times x is 2x, 2 times negative 1 is negative 2, and now I'm back to the type of question that I would have done in my first lesson. So what do I need to get rid of? I need to get rid of subtracting 2 or minusing 2. Now that's a separate term to x, and then I need to get rid of the fact that I'm multiplying by 2. So I would get rid of the subtracting 2 first because it's furthest away from x, so I would add 2 to both sides. So my subtract 2 and add 2 cancel. I'm left with 2x equals 6, and now I need to get rid of multiplying by 2, and so I divide by 2 on both sides, and so I get an answer of x is equal to 3. Now of course I could substitute that in and just check if it works. Now simply because this was a question that had one term equal to one term, so this entire thing on the left hand side is actually one term, I could have done it differently. I could have said to myself, let's get rid of this 2 from the outset. So if I take this side and I divide the whole thing by 2, as long as I divide the other side by 2. So that would mean my 2's would cancel and I'd be left with x minus 1 equals, x minus 1 equals 2. And then if I add 1 to both sides, I would get x is equal to 3. So it's the same answer. Sometimes it's difficult to think of doing that because in some questions that wouldn't actually work out well. And so often it's easier to do my distribution first. Okay, let's have a look at a couple of other questions. Now notice here again, I could possibly divide by the negative 2 first on both sides. I'm going to practice my distribution. So negative 2 times x is negative 2x. Negative times negative is positive. 2 times 4 is 8. And now I'm back to an easy question from the first lesson. I'm first going to get rid of this positive 8 or plus 8 because it's in a separate term. So I'm going to subtract 8 on both sides because that's the inverse operation. And so I land up with negative 2x equals negative 18. Now how's that negative 2 connected to x? It's via multiplication. So the inverse operation would be to divide by negative 2 on both sides. And so I would get x is equal to 9. Now again, here I could have divided by negative 2 first. It doesn't always work out that it is possible, but it is possible here. So I could have divided by negative 2 on this side to get rid of my negative 2, as long as I divide by negative 2 on that side. So what that would leave me with is x minus 4 equals minus 10. I say minus 10, it equals minus 10 divided by 2, which is 5. And then I'm going to add 4 to both sides because it was a subtracting 4. So inverse operations and 5 plus 4 gives me exactly the same answer as 9. Now again, I prefer to distribute simply because I know it always works. So if we have a look at example C is the first example of where I couldn't divide by 3 because I suppose I could, but it just makes my life horrible because then I have fractions, and so personally I would prefer to do this distribution first. So 3 times x is 3x, 3 times 1 is 3. And now I'm back to the type of question that we did in our previous video. This is a Beyoncé type question, simply because I have x's on both sides. So now that this is a Beyoncé type question, I say to myself, which x's are in the supposed wrong place? These 2 x's are in the wrong place. I don't want them there. I want them on the left hand side. So how do I get rid of 2x? I subtract 2x, so that these 2 will cancel each other out. But if you subtract 2x on one side, you must subtract 2x on the other side. So I land up getting 3x take away 2x, which is x, because those are like terms, plus 3 equals 2x take away 2x disappears, which is what I wanted. And now I'm back to a very easy question because all I need to do is get rid of plusing 3 so I'm going to minus 3 on both sides. And so I land up with x is equal to negative 7. Again, you could check to see if you're right. Okay, so this is actually fairly simple. Let's look at the next one. Now have a look. I've got a distribution on both sides of my equation here. So 2 times x is 2x. 2 times positive 2 is 4. 3 times 2x is 6x. 3 times negative 1 is minus 3. And now, I know I did 2 sets of distribution, but I'm straight back to a Beyonce type question. So this 6x is not in the place that I wanted, so how do I get rid of it? I'm going to minus 6x. But what you do to one side, you do to the other side. So now I'm just going to collect up like terms. So 2x take away 6x is minus 4x. Plus 4 is still there. Now 6x take away 6x disappears, which is what I wanted. So now I need to say to myself, right, what is furthest away from x? This plus 4 is in a separate term. So I'm going to subtract 4 on both sides. Now what that means is that these two disappear, and I'm simply left with minus 4x. On this side, I simplify to minus 7. And so finally, I need to get rid of multiplying by negative 4, so I divide by negative 4. And so my answer isn't particularly pretty because it's an improper fraction, but a negative divided by a negative is a positive, so I get 7 over 4. Great, so let's move on to our next one. Now this is probably starting to enter the more difficult things where we need to go a bit slow and write out some steps. Okay, if I have a look at question E, basically my first step is going to be to simplify both sides. You might not need to simplify both sides. Sometimes both sides need to be simplified and sometimes not. Now when we say simplify both sides, we've got to remember our steps from simplifying. Now our steps from simplifying were divide into terms. So you'll see how everything we've done so far this year kind of builds and the skills build. So if I look at my left hand side, most importantly I need to divide into terms. So that 1 is all on its own. And this minus is technically an invisible negative 1, and so now I need to distribute it into the bracket. So when we say simplify both sides, don't forget that your first step is to divide into terms, then simplify each term. So I'm going to write myself a note here, divide into terms, and simplify each term. So in this question, I get minus x, or minus 1x, and then minus 2. And the other side of the equation actually is already simplified. I can't get any better. Now, personally, I don't think that left-hand side is simplified yet, because I prefer to add like terms before I start solving my equation. Otherwise, there's just too many numbers that I have to get rid of. So don't forget that when we say simplify each term, we mean after that, go and add our like terms. So 1 take away 2, so I'm going to put my negative x first, simply because we like to have our x's first, and 1 take away 2 is negative 1. So simplify fully if you want to make your life a little bit simpler in the long run. Okay, now this is a Beyonce type question. So this line here is now a Beyonce type question, and I'm not going to write notes on this because we wrote quite comprehensive notes in our previous video. By Beyonce, we say it a Beyonce type question because letters to the left, to the left, to the left, letters to the left. So that 2x is in the, we call it the wrong place. So I'm going to minus 2x from my right hand side as long as I'm minus 2x from the other side. So now I need to spend a line simplifying. So minus x minus 2x is minus 3x minus 1. And 2x take away 2x is nothing. So I get 4. So don't forget, whenever you've done something, if you've done distribution or you've added 2x to both sides, always just take a line to simplify and then start again. It makes your life easier. Okay, now we're solving a fairly simple equation. So I'm first going to get rid of minus 1, which means I'm going to add 1 to both sides. Okay, now that I've done something, take a line to simplify. So now I get minus 3x, and 4 plus 1 is 5. Now I need to undo multiplying by negative 3. So I'm going to divide by negative 3 on both sides. And so finally, I get x is equal to, now a positive divided by negative is a negative 5 over 3. Again, the answer isn't particularly pretty, but there's nothing wrong with a fraction. Right, let's move on to the next one. Question F. Now this is a particularly interesting one. So my first step was to simplify both sides. Now there's nothing really to simplify. This left-hand side is 2 terms, but I can't add those terms because one's a fraction with a denominator of 3, and I don't really want to add more things to x. So this is a particularly interesting one. And so what I'm going to do here is I'm first going to isolate my fraction. Simply because I'll show you in a moment how much easier it makes my life. So if I have 4x plus 1 over 3 plus 2 equals 5, let me get rid of what's attached to x, but what's furthest away. So what's furthest away is this plus 2. So exactly how I would normally do, I'm isolating x by getting rid of what's furthest away from x. So I get 4x plus 1 over 3, the 2's have disappeared, and I get 3. Now what have I still got to get rid of? We've done this type of question before. I need to get rid of my denominator, and I need to get rid of this 4, and I need to get rid of this plus 1. Now I remember saying in the previous video that I always get rid of my denominators first, because otherwise I tend to make mistakes. So how do I get rid of dividing by 3? I'm going to multiply by 3 on both sides, because then my 3's cancel each other out. So now I'm going to get 4x plus 1 is equal to 3 times 3, which is 9. Okay, now we're fortunately back to our easy question from our first video. So what's furthest away from x is plus 1. So I'm going to minus 1 on both sides. So I land up with 4x is 8. And then I need to remove multiplying by 4. So I'm going to divide by 4 on both sides. And I get x is 2. So this didn't actually have any distribution at all. In fact, I used no skill here that I didn't have in the previous video. It's just that it was a little bit mean because I first needed to isolate that fraction. So don't forget to always get rid of what's furthest away from x first, and then it kind of flows from there. Okay, let's look at some more. Right, here's another fraction example, and guess what? It's already isolated, and so I would first get rid of my denominator and then worry about everything else. So if I write this out, I have 8 minus 2x divided by 4, and that equals 4. So I'm going to get rid of that denominator by multiplying by 4 on both sides, because then it'll disappear. So I'll end up having 8 take away 2x equals 16. Now this is this type of question where most people find it easier to swap things around. So to write the minus 2x first, then the plus 8 equals 16. Now it doesn't actually matter. Either way, you need to get rid of the 8 first because it's a separate term from the 2x. So I'm going to minus 8 on both sides, or I could just put my minus 8 in there. It doesn't matter at all. So either way, I'm going to say 8 take away 8 disappears, 8 take away 8 disappears, and I get minus 2x equals, 8. So it doesn't matter whether you rearrange it or not, the next line will be absolutely identical. Now to get rid of multiplying by negative 2, I'm going to divide by negative 2 on both sides, and so my negative 2 cancel on the left, and a positive divided by negative is a negative. 8 divided by 2 is 4. Okay, so this one looks even more interesting. So back to our steps of simplify each side. So my first step was in simplifying each side was to divide each side into terms. Probably the most important thing I will teach you this year. Always divide into terms. So there's 2 terms on the left hand side. So now what I'm going to do is I'm going to simplify each term. Now in this particular case, that means 2 sets of distribution. So if I look at the first bracket, that'll be 3x. Notice there's no equal sign here because this is an equation. So there's only one equal sign in an equation, and it's there. Okay, so let's go 3x minus 3, and then minus 2x minus 4 equals 10. Now, personally, I would simplify fully. So once you've simplified each term, I would add like terms on each side, simply because it takes an equation that might seem fairly threatening and makes it a lot easier. So 3x take away 2x is x, minus 3 take away 4 is minus 7, and so actually it lands up being fairly easy. So now I just need to get rid of subtracting 7, so I add 7 on both sides, and I land up with x is 17. So basically our rules of how to simplify are just coming into our equations. So we first simplify, and then we solve the equation. Okay, let's look at question I. Question I is another one of these fraction guys. There is a fraction and x is kind of like boggled up in this fraction, and so get rid of everything furthest away from x. So that subtract 4 is in a separate term to x, and so I'm going to get rid of subtracting 4 first, and in order to get rid of subtracting 4, I'm going to do the inverse operation, which is adding 4. So I'm going to add 4 to this side, but my golden rule says I must add 4 to the other side. So these two terms end up cancelling each other out, which is what I wanted. So I get minus 3x plus 1 over 5 equals negative 1. Now, remember that I always prefer to get rid of my denominators first. So how to undo dividing by 5 is I multiply by 5 on both sides. And finally, I land up with something that looks fairly easy. Negative 5. And again, try to get rid of what's furthest from x first. So I'm going to subtract 1 on both sides because that's in its own term. So I get minus 3x is minus 6. And lastly, I can divide by negative 3 on both sides to undo the fact that I was multiplying by negative 3. And so I get x equals positive 2. So you'll start to get used to these. They're all pretty much versions of the same kind of concept. Okay, let's look at what I think is our last one. J seems interesting. I mean, it is just a fraction question. And the thing that's looking a bit interesting here is this negative. Now, that negative is not nice at all, and that negative can lead to quite a few problems. And let me explain to you why. If I was to start normally, and I've said, oh gosh, sorry, that's not x, it's plus, I prefer to get rid of my denominator first. And so how do I get rid of dividing by 3? I'm going to times 3. So this is a fairly logical way to do it. I'm going to times by 3. My 3's would cancel. And then people would think I have negative 4 plus x equals 9. Now, here's the problem with what I've written down here. This negative belongs to this entire fraction. If I wanted it to just belong to the 4, I would have put it next to the 4. But it's not next to the 4. It belongs to the entire fraction. Now, what I've written in my second line here is this negative belongs to the 4. And that's not true. That negative belongs to the whole thing. It's just that the fraction is gone. So if I'm going to do this, I must have a bracket. Simply because that negative belongs to that entire thing. So actually this is minus 4 minus x equals 9. So that's the only thing that makes this question a little bit tricky. That minus belongs to that entire fraction. So once you've gotten rid of the denominator, you still need to show me that that negative belongs to the whole thing. So it actually gets distributed. So I then land up with the fact that I want to get rid of subtracting 4. So I'm going to add 4. That was a separate term. So I'm going to add 4. Don't forget you could swap this if you feel more comfortable. So I'll end up getting minus 4 plus 4 disappears, and I get negative x is 13. Now I need to divide by negative 1 on both sides, and I get x is equal to negative 13. Now there's multiple ways to deal with this negative to make your life easier. I personally would just put a bracket around the whole fraction and say that negative belongs to this whole thing, and so I'm going to keep the bracket until I've distributed in my negative. You could have got rid of that negative right from the start. So you can, if you want to, think of this as negative 4 plus x over 3, and then think of it as negative 1 times the bracket. And then you could divide by negative 1 on both sides. I personally find that a little bit more difficult, so I would prefer to put in a bracket, but it's a little bit tricky. Okay, so that's the end of this topic of bringing in distribution into our equations. Keep going.